Thanks everyone for joining us today. This webinar is hosted by HashiCorp developer advocate Nick Jackson. Thanks for joining us today, Nick. This week we announced actually the Consul 1.6 GA release. You can find the post on our blog. It delivers several long-awaited features for dynamic traffic management at layer 7, along with mesh gateways, which allow Consul to manage secure sidecar proxy connections across separate networking environments. So today Nick is going to demo Consul 1.6's new HTTP path-based routing, traffic shifting, and those mesh gateways I spoke of. So after that, we'll spend the last 15 minutes of the webinar dedicated to live Q&A with Nick available for those questions. This webinar is being recorded, so if you missed something or you want to review, you'll be able to watch it again once we've finished processing and posting it. Usually 1 to 2 days after the webinar. I think I'm going to get this one out pretty quick though. When it's ready, we'll be able to email it out to everyone who registered. So feel free to put questions in the questions box during the presentation. After the presentation, we'll answer them during the QA section. So let's get started. I think I'm ready to hand it off to you, Nick.
All right. So what I want to do today is I want to run through all of the new features that we released, not just in Consul 1.6, but in 1.5, as well as maybe a couple of little things in 1.4. But I want to do kind of a little bit of a deeper dive into how you configure and use those things. I'll talk you through some of the patterns as to why you would use them and how they can be useful for you. And I've tried to build all of my code in a way that you can take this away and you can play with it. So I've got a repo, which I'll share at the end. Lowest common denominator, everything's built just in Docker and Docker Compose, so you can try this all out. I'm just looking at the title I got on my slides there, and Consul L7. So just as a little anecdote or so, L7 was actually one of my favorite bands when I was growing up. They were a kind of a grunge band around the same 90s, the same time as Nirvana, and pretty incredible. So if you get the opportunity to get on Spotify, go listen to some L7. All right, without any further ado. So what we're going to look at, I'm going to go pretty much demo heavy in this talk, but I do want to kind of cover some of the basic background just for some folks who may not be aware. We're going to look at some of the basic configuration. Again, the kind of the level that we're pitching some of these features are, it's a little bit above that, but there's just a couple of things which might be useful for folks. We're then going to look at how you can use the new layer 7 traffic features. We're going to look at traffic shifting. So how can you enable things like canary deploys, dot deploys, and things like that with your services. Multi-cluster gateways, a feature that I am super excited about. Like, how can you span traffic between clusters? Clusters, like, yeah, you could do Kubernetes to Kubernetes, Kubernetes to VM, VM to Kubernetes, cloud to cloud, like you name it. Multi-cluster gateways are incredible and super easy too. Service failover. This is a really interesting thing as well, because like, how do you fail over a server if maybe like all of the instances in a cluster go out? You might have a partial outage in a region. You might want to fail over to another region. It's kind of a really neat thing. And if we've got a little bit of time, I will dig into some of the configuration on how to configure, not so much metrics. I think that's pretty easy and well known, but tracing. I think a lot of folks kind of the configuration on that might be a little bit bewildering, so I'll dig into that. So let's get into going. All right, so why? I promise you I'm going to get through these quick. The reason that we kind of need to look at service mesh these days is because of where we are with our applications. We're running everything dynamic. Everything is like provisioned on demand. You've got multiple clouds, you've got load balancers, you've got auto scaling groups. What you don't have is static IPs, or if you do, they're really kind of difficult to manage. You've got multiple instances of services. So we need to kind of think about a way that we manage the kind of the network transport between our services. not just on a security level, but like, you know, reliability and things like that as well. And the cloud landscape is just getting more and more complicated and more and more bigger. I mean, the number of different features that are appearing in the clouds is becoming more advanced. On-prem sort of hardware, such as like VMware's tooling, Cloud Foundry, OpenStack, you know, that all of these tools are getting bigger and more complex and managing the kind of the more modern workloads. We sometimes need to kind of bridge between the two. I mean, depending on the scale that you're operating, you know, you might be running multi-cloud, and you might be doing that for a number of different reasons. You might be doing it because you want to do it because you want to hedge your bets on one particular cloud. More likely, you've maybe working in a large company that's gone through an acquisition, and part of the organization uses Azure, part of it uses AWS, part of it uses GCP, and maybe you've got some stuff in private cloud. How do you link all that together? It's Consul Service Mesh. So this is literally kind of where we're aiming at with Consul Service Mesh. The kind of that concept of enabling that sort of multi-cloud or multi-cluster configuration, being able to allow you to get rid of the need for having multiple networks, which kind of are interoperable, either connected through VPNs or you've got just one big flat network. Now, Consul is not just for multi-cloud. Consul is not just for big systems. You can run Consul with a handful of services and you can still get all of the benefits. The beauty of it is it scales. Like, you can run a single server on a very small or modest virtual machine, and you can run 7 servers on huge 32 core, like large memory machines. It scales right across your sort of wherever you are in your development lifecycle or your development history, or just whatever kind of application you've got. And we try to make it easy. So again, kind of touched on that sort of earlier, but it's that, like, that monolith to microservices thing. Like, not a day goes by when I don't read criticism that microservices are not the right approach, but then again, not a day goes by when I don't read criticism when monoliths are not the right approach. You know, the thing is around a service mesh is that if you've got the right kind of connectivity, it can enable multiple monolith communication. I mean, like, again, you know, it depends on what do you define a microservice, but anyways. But the core problem around that is that dynamic infrastructure. We've got multiple instances. We don't know what exists and what doesn't exist because it changes all of the time. Auto-scale groups are kicking in. Services are rebooting, they're getting moved. You know, we need to be able to manage our network traffic and our network routing on a very much a dynamic basis. We can't just kind of take static IP or location-based infrastructure very easily with modern systems. API. Infrastructure as code wouldn't be HashiCorp if we didn't talk about infrastructure as code, and all of our tools are driven around the fact that you can kind of codify all of the interactions with them. We'll look at a couple of different ways, but you know, however you want to do that, Terraform, Ansible, Chef, Puppet, Bash scripts, the interactions there for you to manage. All right, now. So again, I'm pretty much at the end of the background. We're going to dig into the meat now, but just again, for some folks, just in case you're not familiar with how a service mesh works, service mesh is broken into 2 components, data plane and the control plane. The data plane or the proxy is the thing that's used to connect instances. So data plane talks data plane. No service traffic talks direct. So in this example, we've got web and database. The web service doesn't talk directly to the database, it talks through the proxy. The proxy is the thing which is potentially layer or protocol aware. It is the thing which understands your service catalog and your service discovery. It's the thing which can manage all of your reliability patterns. It's the thing which can kind of handle observability. It means that your web application can remain dumb. Like, when we first started moving to microservices, we just lumped all of that kind of reliability and service discovery into the application service. We created fat services. Many folks who've pioneered that approach have kind of looked at this better approach, this decentralized approach, and that's the service mesh. So we're going to be doing this. We've got these sidecar proxies which accompany our web applications or our APIs or databases. So some basic configuration. So anybody who's used Consul before might be kind of aware of this kind of service configuration. So what I've got here is the very basic service registration. I've got the name of my service and the port to which it's accessible. And I would register that in Consul either by dropping it in the config directory of the local agent, or I would use the CLI or the API to register that. But with Service Mesh, what we've done is we're expanding that ever so slightly. So you've now got this new connect stanza block. And inside this connect stanza block, we can do things like configure our sidecar service. So which port do I want it to listen on? What is the local service address? So the sidecar has to talk to your local service. And upstreams. So the previous slide, I talked about the fact that all of the service discovery is being moved out into these decentralized sidecar services. Whenever I want to talk to an upstream or another service, so if web wants to talk to API, it doesn't need to worry about domain names or IP addresses or anything like that. All it does is talk to localhost on port 8003 and Consul Service Mesh, and the sidecar proxy will manage all of that routing for you. So just a couple of blocks there. And a new feature which we introduced, I think it was version 1.5, I could be wrong, but what we've introduced is a concept of being able to manage the service configuration. So much of the configuration around protocol and things like that, you can put in the service definition, but we've created this concept of central configuration, which means that any configuration defined in central config, so for example, this service default, when I start a service with the name web, it will automatically inherit any of this configuration. So again, it's making it super easy for you to configure your services in the mesh, and all of the new layer 7 features rely very, very heavily on this. Oh, okay. So in addition to the HCL approach that I was just showing here for central config, you can also define your central configuration in JSON. So we support both. The structure is the same. Obviously, you just deal with the differences between HCL and JSON. I'm going to show you all of the stuff in HCL because I think it's cleaner and easier to read. So what are the types of configuration? What are the ones that we're going to look at today? So we're going to look at proxy defaults. That allows you to control proxy configuration, defining the protocol for layer 7 capabilities, HTTP, gRPC, defining service defaults, so things like your metrics and your tracing configuration. You can configure that globally in central. Service routing, so we can kind of set up sophisticated layer 7 routing patterns, service splitting. So that's kind of how you would do things like canary deployments, but you can basically portion part of your traffic to various different service instances, maybe service versions. And service resolver, which is allows you to define virtual services, which are used by service routing, service splitting, things like that. So there is a process. So you got to think of it as in terms of a layering approach. So whenever you define your configuration, routing is the first thing that's handled. So things will go through a service router, then they'll go through a service splitter, and finally they go to the service resolution stage. Now, you can use these independently. You can go straight from routing to resolution or splitting to resolution, or you could just use resolution itself. But it's just a little important fact to remember whenever you're setting up this configuration. So let's dig in. So let's have a look at traffic routing. So what am I going to do? So I've got a kind of a typical kind of approach. I've got some traffic which is going to come in, and I want to do path-based routing on an upstream. Now, this is not kind of an API gateway level stuff, but for example, I might have an upstream where I can't separate it out into two separate endpoints. So I want to send traffic to / and that's going to go to my website service, and if the path is API, I'm going to send it to my API service. Configuration is really quite nice and simple. So we've got this service router stanza, the name, which is what is the service to which that's going to apply. I'm applying that to API, and then I can define these routes. So I'm just showing you path matching in this simple example, but you can do things like HTTP headers and regexes and things like that. But in essence, what I'm going to define is that I'm going to define these two different routes. I'm going to have my V1 and my V2. So my V1 route is going to go to my API V1 service, and my V2 route is going to go to my API V2 service. So maybe I'm breaking up a microservice here, and I can't touch the downstream web service. It's just a way of enabling that. So let's take a look. All right. So what I've got is, and I've built all of these examples in Docker Compose because it's that easy. You don't need any complicated hardware. I'm running a, I don't know, like MacBook Pro, like 16 gig of RAM or something. It's not a massively new machine, so it'll handle it just fine. So I'm going to create my Consul server, and my Consul server has got no real special configuration with the exception of this bottom bit here, right? Whoops. So what I need to do when I'm setting up and configuring Consul is I need to enable gRPC, because the data plane communicates with the Consul service mesh or the control plane using gRPC. So this is disabled by default. So I have to enable that in my server's configuration file. And then I enable connect. So that's switching on the service mesh capabilities of Consul. And lastly, I want to enable this central service configuration. So just really those three extra blocks that you would use. Nothing too unusual there. So I've got my Consul server, and I'm just going to expose my Consul server to localhost so I can interact with it. I'm using hard-coded IP addresses just to kind of get around Docker and Docker Compose, but I've got my web service, and I'm just simulating all of this stuff. I'm using a tool called Fake Service, which allows me to fake requests upstream and all sorts of good stuff. And I've got my sidecar, so I'm using Envoy here, and I've just got this this convenience again because I'm building this around Docker Compose, but my Envoy is going to register my service as well for me. So let's take a look at that service configuration. Again, pretty similar to what I was showing you earlier. I'm using the optional health checks for my sidecar services, specifying a port, and importantly, those upstreams. So upstreams have to be explicitly declared, right? So if you've used Consul Service Mesh before, this is not new, but if you haven't, then I want to explicitly declare an upstream to my API service, which is going to be running on port 9091. So web will be able to make requests to API using localhost 9091. And then I've got my API service running, which is just an HTTP service. Again, I've got some pretty straightforward service configuration, even simpler than last time because I'm not specifying an upstream. And I've got API v2. So my API v1 is just going to broadcast the message API v1, and v2 is going to be broadcasting v2. So what I want to be able to do is I want to be able to curl localhost 9090 v1. And if I do that, I should hit my v1 service. If I do v2, I'll hit my v2 service. So let's look at the configuration that's involved in doing that. So the first thing that I want to be able to do is configure my service default. So a lot of the stuff that we're using is layer 7, so it's protocol aware. So I need to tell Consul that my API service is a layer 7 service and it's using the HTTP protocol. I'm going to do exactly the same with my web service. So I've got those 2 bits of central config there. So before I apply those, let me just start those services, because you can actually configure this on the fly. Traffic routing. All right, and I'm just doing Docker Compose up. So again, I've got a link for you. You can look at all of this stuff. My Consul server now is running. We've got our API v1, our API v2, and our web sidecar proxy. It's just going to take, there we go, a couple of seconds for those to go healthy, but they're all up and running. I can kind of click through, it's just your standard Consul UI. I can see my checks there. I can see my upstream definition, all nice stuff. But if I kind of curl my service right now, it's not going to work because I need to configure that service routing. So first things, let's apply the defaults. And I'm in the wrong folder. Okay. Right, so let's apply those. Consul config write API defaults. Easy as that. And web defaults. And I'm going to apply my API v1 defaults and my API v2 defaults. So you're probably asking yourself, hang on a minute, you've only got 2 services. Why do you apply 3 levels of configuration? Well, the reason for that is because if you look at my actual service configuration, you'll see that my service names are API v1. But what I'm actually addressing them as in the destination is API. And that's because I'm using a virtual service. And I configure my virtual service with this service router. So I've got my service router block, I've got a name of API, and I've got these routes. So v1 is going to go through to physical service API v1. v2 is going to go to physical service API v2. So again, just looking into here, there's no API service name registered because I'm going to use that virtual service. Virtual services and physical services, if they're going to be used with any service router or anything like that, got to have those service defaults, which are declaring that HTTP protocol. So let's apply that. Consul config write API, router. Right, now curl localhost 9090 v1. And there we go. So that wasn't working before, but now it's routing to API v1. So what if I route to API v2? There we go, got API v2. So really straightforward. And if I like updated this, let's say I just want to call this vnew for whatever reason. I'm just going to reapply that configuration. Just going to give it a little second for it to apply. Curl localhost 9090 vnew, and there we go. We're on the V2 API. So really, really kind of, I hope, straightforward. So let's move on. Let's now look at traffic splitting. So I'm just going to kill that and dive back into my diag. All right. So traffic splitting, this enables you to do things like canary deployment. So what you might want to be able to do is launch a new version of your service, and you want to be able to send, let's say, 10% of the traffic to the new service. You want to just kind of validate that it runs fine in production before you kind of roll it out completely. So again, we're going to use the service resolver, but this time instead of defining routes, we can define subsets. So I can use console metadata, or I can use console tags, anything that's kind of available through the filters. And I can define these subsets, V1 and V2. I can then define my service splitter, and I can say, right, I want a 50-50 split between subset V1 and V2, or anything. Those splits have got a total 100, so it is a percentage, but it's pretty straightforward. So let's take a look. Whoops, daisy. All right, so CD traffic splitting. So again, let's take a look at the setup here. So I have my console server, I've got my web service, and I've got my version 1 of my API in one of my files, and I'm going to start these separately. So I've split these over 2 Docker Compose files, but then I've got my V2 service, which is going to be in a different file. So I'm just going to run that. Right, so that's running. And again, I've got to apply my configuration. Okay, so let's take a look at that configuration. So again, I've got my service defaults. So that's pretty straightforward. We saw that in the same example before. So console config write API service defaults, and that's configured. So if I just curl my localhost 9090, you can see that I'm just going to get my responses from my V1 service. Now, what I want to be able to do is I want to start my V2 service, but I don't want to just start my V2 service, because if I do, let me show you what's going to happen. Whoops. Docker compose up, oh no, -f V2 up. All right, so I'm going to start my second service. We can see all of that is running here in console. So I've got my API, now single service, but you can see it's got tags as V1 and V2, and that's just through the service config. So nothing unusual there, standard stuff. I've got metadata V1 and V2. Now, if I curl that, what I'm going to get is I'm just going to get standard round robin load balancing, because both of those services are available inside the service catalog. So what I need to do before I launch my second service is I need to apply my service split. And I want to define my service split so that 100% of my service traffic is going to go to V1. So regardless of any other service that I start, only V1 is going to get the traffic until I'm ready. Again, I need that service resolver that we saw earlier. So the service resolver is defining that the API service has these 2 subsets. The V1 subset, which is looking for any service in the catalog with the name API, which has the metadata version 1, and the same for version 2. So let's run those. So again, console config write API, service resolver, and let's set that service splitter to 100% v1. Curl localhost 9090. All right, that's pinned 100% now to our v1 service. So I'm doing a canary release. I launched my second version. I'm pretty confident. So let me update my service config. I'm going to just go with a 50-50 split because, you know, YOLO. So console config write API service my service splitter. It's late in the UK. Give me an excuse for not being able to type. And now, if I run my curl again, I'm going to get V2, V1, V2, V1, V2, V1. So I'm going to get approximately a 50-50 split across those services. So we look at our metrics. We're happy everything's working fine. So what we want to do is we want to roll it completely over to our V2 service. So again, we're just going to apply that same console config write service splitter, and I'm going to specify 0% to V0 service 1 and 100% to V2. Apply that. Curl localhost V2, 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 V2. Pretty easy. I mean, if I can do it, right? So let me just quickly, before I forget, stop those two services. Otherwise, it will screw up on my demo later on. Come on, keyboard. All right. So moving on, and I'm apologizing if I'm going through this at a rate of knots, but all of this config is going to be available for you to kind of plow through at your leisure. What I want to show you next is something which I'm really, really excited about, and that's multi-cluster gateways. So multi-cluster gateways allow you to bridge traffic between two completely separate clusters of services. So in this example here, I've got two Docker networks, and the Docker networks, they can't talk to each other. This could be a Kubernetes cluster and a virtual machine cluster. Again, I'm just using Docker to simulate these things for simplicity. But the two console servers, I'm setting them up as independent data centers. They federate that service traffic and central config. So I only need to write my central config in one location. It's automatically going to get sort of federated and copied across to the other data center. But the gateway acts as a bridge. So when web wants to talk to API in another data center, it does so through these console gateways. And console gateways are just lightweight proxies. They've got no way of decrypting traffic. So all of your traffic in your service mesh is MTLS. And it is between the gateways. So it's even safe to put these gateways bridging clouds. You can't decrypt the traffic on the gateway. It's passing through. We actually use SNI headers inside of the HTTPS request for the gateway to discover where to send things on to. And they are great. So again, to kind of enable a service to use a mesh gateway, I'm going to use the service defaults mesh gateway stanza. There's two modes. You've got remote and you've got local. With local mode, it's going to take exactly this approach where it will talk to its local gateway first. The local gateway talks to the other cluster's gateway, which then talks to the upstream service. If I was using remote mode, then remote mode means that I'm going to bypass my local gateway and I've got egress to be able to talk direct to the remote cluster gateway. So you can save yourself a hop if you've got that capability. So let's have a look at how we configure those things. So again, I've got this Docker Compose file. So I've got my console data center 1, and I've got my web service. I've got a gateway running in my web service. And this is the command that I'm using to run my gateway. I'm basically just using Consul Connect Envoy Mesh Gateway. I want to register it. I'm specifying an address and a WAN address because the gateway is the only thing that needs to be accessible from the other gateway. So it's running on a different WAN, on a WAN network in this case. Got my networks, and I've got my second data center. And we'll look at the configuration for that in a second. But in my second data center, I've got my API service. Again, a gateway, which is communicating on the WAN address. And just to sort of simulate those things, I've got 3 networks set up in Docker Compose. Different IP ranges. DC1 cannot talk to DC2 because those services are not on the same, are not connected to the same networks. The only way that the services between the 2 data centers, or DC1 and DC2, can communicate is via the WAN and the gateways. So in order to do this, and this is using the new, well, it's not a new, it's an enterprise feature which we dropped down to open source to enable gateways. We've got these new configuration options. So I can specify my primary data center. So DC1, primary data center is DC2. I've got to set that on all instances of my federated system. I'm going to set my advertise address for the WAN. So that is the WAN address that the console servers will communicate on, because they need to share that configuration and the service catalog over the WAN gossip. So I specify that. And then in my second data center, pretty much the same, except I've got DC2 here. Primary data center is DC1. I've got my advertise address and my WAN advertise address. Again, that's the IP address that I'm going to use for DC1 to talk to me. And I'm doing retry join WAN. So this is the command which is going to join those 2 separate console data centers together. And I'm just specifying the IP address of my first data center. So let's just run that first, so we can kind of have a look at how that looks in the UI. So Docker Compose up, and we'll run that. All right, so that's spinning up. So let's bounce over here to our console UI once it starts. There we go. So again, DC1, you can only see I've got my web service here. I'm going to communicate as an upstream to the API, which is in the separate data center. So that will join in just a moment. It's just going to take a couple of minutes for it to join. So let me see the console members there. And if we look at the WAN, okay, so we can see that the console cluster is now federated. I was a little bit hasty, 30 seconds, it's just too slow, right? But now from my console UI, and I'm attached to DC1 here, I can actually see all of the DC2 services. And this has just come up there. So that's pretty cool. All of the intentions, all of the centralized configuration when using a federated cluster, it's just going to all replicate for you, all of the identity. So let's take a look at our example. So again, I've got that localhost service running on 1990, and it can't talk to the API because there is no API service running in DC1. So what do? Well, again, I'm going to apply those API defaults and web defaults. Now this time, I'm actually got a web service which is talking to a gRPC service, because I'm just mixing it up a little, but I'm going to show you that you can send any traffic across those clusters and the gateways. So let's set up those defaults first. So console config write, and I'm just going to do my memory API defaults and console config write web defaults. Okay. So this is still not going to work because what I need to do is configure a service resolver. So the service resolver is kind of that virtual service or service override in the case that I actually do have a service called API, but I'm saying that for all traffic to the service API, I want you to redirect to a service called API in data center DC2. Now that could be any service name that you want that's registered. I might have it called API v2, I might have it called, I don't know, Jane, White, anything. But any traffic that's destined for API will be routed to this service in data center DC2. Console config write API resolver, and that will take a few seconds just for that configuration to write. Don't you call me a liar, computer. Curse of the live demo. I can promise you this was working. I apologize, but I've failed. My demo is not playing nice, but you can check out this example in, let's see if I can just get it working, in the repo, and I can promise you it does work. Just wait for that to start up. Just waiting for those federations to happen. There we go. See, it is working. I must have just fat fingered something. But all of that traffic is going from data center 1, which has no API service running. It's flowing across to data center 2 via that gateway running in the WAN port and to the destination, which is pretty awesome. Very, very quickly, let me just quickly fly through this last and final demo. So one of the things that you can use gateways for, in addition to kind of just bridging clusters, is you can use it for things like service failover. So for example, if you do like a follow the sun type pattern where you've got a region in East US, West US, Europe, Eastern Europe, if the instances of a service fail in a particular region, then using gateways, what you can actually do is you can route that traffic out into another data center or another region. So, I mean, that approach is not ideal because you're going to get latency, but it's certainly better than downtime. So very, very straightforward to configure. Again, we're using that service resolver, but this time I'm specifying that my failover for API is going to go to data center DC2. And if I've got more than one data center, I can specify those as an array. So let's just quickly run through that. Failover, Docker compose up. So again, same configurations here. I've got my API defaults, my web defaults, and my resolver. Just in case you're interested, we can specify those as JSON as well. But okay, so console config, right? So the default for this is going to be that the location for the traffic is going to be to its local instance. Right, so let's get that up and running. So in DC1, I have console, I've got my API, and I've got my mesh gateway. In DC2, I've just got my API. So in my configuration file, I've just got my API in V1 to be announcing itself as API DC1, and then API in V2 is just DC2. So curl localhost 1990. So you can see that that is always going to hit DC1, whilst there are available instances of that service in DC1. So let me just brute force this thing. Let me just kill it by force with fire. Yeah, not that. Always have a cheat sheet handy. Right, kill. So what I've done is I've just killed my API instance in DC1, and it's gonna take a while for the health check to pick that up. So, oh, well, it's already done it. I didn't get a chance to show you that there is obviously going to be a small transition when it's detecting that the service instance has failed based on the health check. But you can see now that because I don't have any healthy instances of API, I'm automatically failing over to my second data center, which is kind of neat. You know, you can mitigate the kind of the delay between the health check kicking in and stuff by using some of the reliability patterns, but I'm just trying to keep things simple for everyone today. I'm not going to have time to delve into metrics and tracing, but I will share these slides, and the example is in the code repo. But I want to say thank you very much for listening to me today. If you've got any questions, you can hit me up at nick@hashicorp.com, or I'm always available on Twitter at Sheriff Jackson. Follow me, get me to that 3,000 follower mark, because I've got loads of great stuff to say. And those examples, the things you've been really waiting for, but you can grab this this link here. So github.com, Nicholas Jackson, demo-console service mesh. All of those examples are built in Docker Compose. So all you need is either Docker for Mac, Docker for Windows, or Docker on Linux. And you can work through all of that configuration. By default, all of the central configuration will automatically be applied for you. So it's nice and easy, and we'll send that link out. If you have any questions around sort of layer 7 console service mesh or any of the HashiCorp products, you know, please use the community forum at discuss.hashicorp.com. There's always engineers and our dev advocacy team and all sorts of folk who are more than happy to answer any questions there, and you might find it a little quicker than GitHub issues or something. And with that, I'm done. And I guess it's questions from you all now.
Yeah, I think we've got about 5 or 6 minutes for questions, so I'll just jump right into them, Nick. This one's like a little bit of confusion around tooling and what works for what maybe. So here's the question, kind of verbatim. Could or should Consul replace Nginx as a proxy, or is it still better to use Consul template and replace config files, thinking about Consul agents and sidecar?
So I think like personally, Nginx is an incredible tool. It's very, very powerful. So using Nginx as your API gateway, so your edge ingress into your cluster is an incredible thing to do. Nginx supports a lot of stuff around like authentication, and especially if you're running like the enterprise versions. With the service mesh though, you can absolutely do this decentralized approach by having these individual sidecar proxies. So rather than relying on like centralized load balancing internally, if you're using the service mesh, you get the benefits of the security by the authorized and authenticated secure transport between your services, but you're also reducing the latency because the only hop you've really got is on the internal kernel on localhost between your service and the service proxy. You don't have to route out to a central service, which is in a different machine before you potentially bounce out. So as a pattern, I've run the centralized load balancer approach. I am super keen on this decentralized approach now. So I would advocate Nginx as your ingress. Keep it like that. Use it as your edge gateway. Consul service mesh for your internal routing traffic.
All
mesh
right.
Between your clusters.
Next question is, would there be any issues expected if one were to run a Consul cluster to be used as a storage backend for Vault via Connect?
Could you do that? I mean, you theoretically could do that. Because you could register a proxy to Consul, which would expose Consul's API on 8500 and then do the same thing with Vault at the other end. I've never tried it. I can honestly say it should work because all you're really doing is routing HTTP traffic. So give it a go and let us know your feedback. Please hit me up on the community forum. I might have to have a little play with that, but theoretically, I can't see any reason why it wouldn't work. I think the latency is going to be low enough, and the way that Vault manages the data backend anyway is Vault's caching a lot of the secrets in memory, or caches as much as it can in memory to give you that super fast access. So yeah, theoretically that'll work.
Great. This one has two parts. Kind of how does Service Resolver compare with prepared queries, another feature of Consul? And which is the best approach? Is the Service Resolver going to be available on the Consul Terraform provider also, was the question.
So all of the layer 7 capabilities will be available in the Terraform provider. We just haven't released that as yet. We're currently working on getting those updates in there. Prepared queries, I mean, if you're using Consul Service Mesh, I would advocate that you use service resolvers rather than prepared queries, because I think they're easier to reason and easier to configure. Prepared queries you can also use with Consul Service Mesh. Prepared queries you can also use with non-service mesh functions, so just standard kind of Consul DNS or Consul Service Catalog queries. So I would say it depends on what your use case is, but if you're just running like Consul Service Mesh, I would use the new Service Resolvers. You get a lot more sort of a lot richer capability than you get out of prepared queries.
All right, I think we've got time for one more question. Does Consul's intentions, do they replicate to a second DC for the mesh gateways to allow connections?
Yes, they do. Yeah, so have I got this thing running still? Let me see if I've actually got, I think I've got both of these running. Do I? Yes, I do. Good, Nick. So I'm going to go over to DC2, which is my DC2 intentions. Let me go over to DC1 intentions. I'm going to create an intention. Let's just create a deny all. I am going to save that. I'm going to go over to my DC2 server. There you go. So yes, intentions replicate cross data center. So you don't need to worry about having to configure it in 2 different places at once.
All right. Well, I think we're going to wrap up then. Thanks for those answers, Nick. Thanks for packing all those demos into one webinar. And thanks to everyone who submitted questions.
Yeah, and please, hit us up on the community forum, discuss. We'll send out all of those links at the end of the webinar, but if you've got any use cases, you want a little bit further clarification, it's an absolute pleasure to help.
Perfect. And hope everybody learned, a little bit more about Consul 1.6, what's there now. For more webinars, you can visit our website at hashicorp.com/events. To view our archive of previously recorded webinars, you can go to hashicorp.com/resources and filter by webinar. And finally, as I mentioned, this webinar is recorded. We'll make the recording available on the HashiCorp resource library after processing, typically in a day or two. We'll email that as a link also to everybody who registered. So thank you so much, everyone, and have a great day. Thanks for joining us.
Latest.